Hello everyone, welcome to the channel TopGate. In this video, I'll discuss multi-programming operating system, and in the previous lectures, we have already discussed the introduction to the operating system as well as the state transition diagram of a process. Fine. So let's start the video. So in this one, as the name says, that it is a multi-programming operating system. What does that mean? That means that it is an operating system which has the capability to make the system as a multi-programming system. What does that mean? If we are saying that it is a multi-programming system, that does not mean that the CPU is executing more than one process at a time. That means it is the operating system which is trying to make the system as a multi-programming. In the previous video, we have already seen that a process migrates between two bursts in its lifetime. That is, it starts its journey from the CPU burst, and then after doing some CPU bursts, it goes to the IO burst. Fine. Now, what is CPU burst? CPU burst is the time for which the process is executing on the CPU, and the IO burst is the time for which the process is using the input-output devices. Fine. So suppose there are several processes which needs to be executed by the CPU. So when they are in the new state, they inform the operating system that now they are ready to begin their execution. As soon as they inform this to the operating system, the long-term scheduler will pick those processes from the new state and it will shift all those processes to the ready state onto the RAM. Now all these processes which are there onto the RAM and waiting for their turn to be executed by the CPU, then the short-term scheduler will pick any one process from this RAM and it will send it to the CPU for execution. Now suppose the CPU is executing this program, and after executing it partially, this process says that now I don't want to continue my execution. Why? Because I need to do some input-output event. That is, suppose it requires some input from the user or it requires some data from the secondary storage. Now doing all these things will actually require some time. Fine. And we don't want our CPUs to sit idle for this time. So what the operating system says, it will say to the process that if you want to do some input-output event, or if you need some data from the secondary storage, or if you need some input from the user, so that will actually take time and I cannot keep my CPU idle. So it's better that you should leave the CPU for a moment and you go to the waiting or to the block state. Fine. Now this process will leave the CPU for a moment and it will go to the block state, and there it will try to use the input-output devices, or it will try to complete the event which it requires for its completion. Fine. Now while this program is into the block state, the short-term scheduler will pick another program from the ready state from the RAM and it will send it to the CPU for execution. Now shifting the CPU from one program to another is called as the context switch. That is, the CPU is switching its context from one process to the another. Fine. So this is called as multi-programming. That is, it is executing one process at a time, and when this process said that now I cannot continue my execution, I need some time for doing input-output, so the operating system will switch the context of the CPU from that process to another process, and it will send the previous process to the block state or to the waiting state. Now after that process complete its work, complete its input-output event, or it gets the input from the user or from the secondary storage, it will be again sent to the ready state onto the RAM, and there again it will wait for its turn to be executed. Fine. So if there are n number of processes which needs to be executed on the CPU and they are waiting for their turn onto the RAM, the CPU will never sit idle, and that is the most important thing in this one, that we are trying to make our systems as busy as possible. Fine. We cannot make our systems sit idle for a moment. Fine. So this is the whole idea of multi-programming. So let's discuss this with the help of this diagram. In this diagram, we can see that there is a CPU and we have a main memory and we have a secondary memory. So overall, this is actually a computer system. And in this one, the main memory is loaded with the operating system first, and then it has multiple programs which needs to be executed by the CPU, and all are ready for their execution. Fine. They are in the ready queue. Now, one process from this RAM will be sent to the CPU for execution. CPU will start executing that process, and while it was executing, the process may need to do input output burst. So at this time it will inform the OS that now I need to complete some input output event. So the operating system will ask this process to shift from the CPU and go to the waiting state. Fine. And another process will be taken from this RAM. It will be sent to the CPU for execution. That is called as the context switch. The CPU is switching its context from one process to another. Clear? So let's discuss this with the help of these some points. So first point says that multiprogramming means more than one process are ready to execute and are waiting for their turn on the RAM. That is, there are multiple processes which are ready to execute and they are waiting for their turn onto the RAM, and all this is done at the process level. It is not done onto the OS level or to the CPU level. Why? Because the operating system is not saying that I don't want to execute this process. It is the process which is requesting the OS that now I want to do the input output event, or I don't want to get executed on the CPU for a moment. So it is the process which is requesting the OS. It is not the OS or the CPU which is asking the process to go to the block state. Fine. The second point, CPU utilization is increased. Now that is the most important point. This is the point why we are doing multiprogramming. We are doing multiprogramming just to increase the CPU utilization. Now next point, context switch between process, which occurs when the outgoing process goes into waiting state. Fine. So we are doing context switch when the process itself voluntarily it is going to the waiting state. Fine. So process it is the requirement of the process to go to do the input output event. So while it is doing the input output event, the CPU execution cannot continue. Therefore the OS is shifting that process from the CPU to the waiting state. Fine. And the fourth one, the CPU idle time is reduced. That is the most important thing in this one, that we don't want our systems to be idle at any moments of time. We want our systems to be as busy as possible. Fine. So the basic idea behind this multi-programming operating system is that we want to increase our CPU utilization, and while one program is doing the input output burst, we don't want our CPUs to sit idle. Therefore we are taking another process from the ready queue and executing it on the CPU. Thank you so much.